हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं। देखिए राइट, इस क्वेश्चन में क्या है, यूनिफॉर्म सॉलिड सिलेंडर ऑफ मास m and radius r is set into rotation about its axis with angular velocity omega naught. This is omega naught, then lowered with its lateral surface on the horizontal plane. Coefficient of friction दिया है सिलेंडर एंड प्लेन के बीच में म्यू. द टाइम आफ्टर विच द सिलेंडर विल स्टार्ट विदाउट स्लिपिंग, आई मीन राइट रोलिंग विदाउट स्लिपिंग हो जाए कितने टाइम के बाद. तो लेट अस सी, अभी क्या है, ये ओमेगा से रोटेट कर रहा है और रेडियस आर दिया है ना, तो इस पॉइंट की वेलोसिटी इस डायरेक्शन में कितनी हो जाएगी, ओमेगा नॉट इंटू आर. अभी है राइट, आई मीन इसको सरफेस पे रखने से पहले ओमेगा नॉट आर थी लेफ्टवर्ड डायरेक्शन में. जब इसको सरफेस पे जैसे ही रखेंगे उसके बाद एफ बी डी क्या होगा आफ्टर प्लेसिंग ऑन सरफेस. लेट अस सी, राइट, आफ्टर प्लेसिंग ऑन सरफेस ये जो स्फीयर है इसके ऊपर फ्रिक्शन फोर्स लगेगा. सिर्फ दिस पॉइंट ऑफ कांटेक्ट इज गोइंग इन बैकवर्ड डायरेक्शन, तो फ्रिक्शन विल अपोज बाय एक्टिंग इन फॉरवर्ड डायरेक्शन. तो इसके ऊपर फ्रिक्शन लग जाएगा F, and value of friction will be kinetic, so Fk will be equal to N into mu, and as you all know the normal force will balance the mg here, so this will become mg into mu. So this is the friction force acting in forward direction. So what will the acceleration of center of mass, you can say acceleration of center of mass will be equal to Fk upon m, because in the horizontal direction there is only one force, that is kinetic friction, so that will be Fk upon m, so this will become mg mu upon m, so that is equal to g mu, and that will be in rightward direction. Okay, because Fk is actually in rightward direction. So now I know the acceleration of center of mass will be in rightward direction, g mu. Okay, now due to this force there will be torque also about this axis, so let us calculate the torque now. So torque will be equal to F into distance from the axis of rotation, that is how much, Fk into r. So torque will be Fk into a small r. So what is the torque now, Fk is mg mu into r. So I can write here torque is equal to I into alpha also. So let us see, I will be how much, this is the cylinder, so moment of inertia of cylinder is mr square upon 2, so this will become mr square upon 2 into alpha is equal to mg mu into r. So now we can say this m will get cancelled out from both sides, this right, this r will get cancelled out and one r will be left. So from here I can say alpha r is equal to 2g mu. Okay, now you can say the alpha r is equal to what, a tangential, so I can say the a tangential will be equal to 2g mu. So this is the equation 2, and this is the, and this is, let us say, the equation 1. So let us see, right, so let us now concentrate about this point, right, let us call this point is C or something. So you can see here, due to translational motion what is the acceleration you are getting, g mu, and due to rotational motion and due to this rotational impact how much acceleration you are getting, 2g mu. So due to translational and due to rotational, how much total acceleration the point C will get, C, right, due to rotation also it get is in a tangential in rightward direction only, you can say right direction towards right. Okay, and due to translational motion also acceleration it is getting in right direction, so this is also in right, है ना. So due to translation g mu in right direction, point C is getting acceleration, and due to rotation also this point C is getting acceleration which is equal to a tangential in right direction. So total acceleration, right, total acceleration, or you can say like, right, acceleration of center, that is C I am taking the lowermost point, total will be equal to, due to translational what is z mu in rightward direction plus 2z mu that is also in rightward direction. This is due to translation and this is due to rotation. So total you will get 3z mu that is in right direction. Okay, so now I know the acceleration of C that is in right direction, and initial velocity I know that is omega r. So if you want it to roll without slipping, so it means the point C should come at rest. Okay, then only there will be no slipping. Okay, so let us see after how much time this point C will come at rest. So you can use the equation of motion here because the acceleration is constant. So now you can easily see V is equal to U plus AT. So finally for the rolling without slipping, V should be 0. So V is 0. Initial velocity is C how much? Minus omega, right, let us take leftward direction, minus omega naught R into A. Acceleration is how much? 3g mu into t. So from here I can easily say that t will be equal to omega naught R divided by 3g mu. So this will be the answer. Okay students, I hope you understood this question.